All right, a ball is dropped from a height of 10 kilometers, 10 meters, 10 kilometers. That seems a bit drastic. It's a very cruel thing to do to a sphere. We want to know its speed when it hits the ground. We want to know how much time it takes to hit the ground and how much energy has been dissipated if it only rebounds to a height of 9 meters. That one annoyed everybody. Let's do A and B first. So the speed when it hits the ground, v squared, is v naught squared plus 2a x minus x naught. A very nice problem for us to do. So that means we have here v when it hits the ground equals, it starts at the speed of 0 plus 2 times negative 10. Its final position is when it hits the ground, which is 0, and its initial position is 10. So we're going to basically get a speed of about 14 meters per second. Now, if we're looking for the time it takes to hit the ground, there's several things we could do. I'll do v equals at plus v naught, and we can basically say here, I guess if you want to be really technical, we should make this a negative 14. I won't grade on negative signs. I won't grade negative signs, just so you know. Negative because its velocity is downwards. So v equals at plus v naught means we'll end up getting a speed of negative 14 equals negative 10t plus 0. Whoops, so gross. This writing tablet's being very, very weird. Negative 10 times t plus 0. And so when we work out our time, it ends up being 1.4 seconds. Now for part C, we want to know the energy that it has if it rebounds only to a certain height of 9 meters. So we start off with all Eg, and then when it rebounds, it's going to have some Eg and some E dis. Sorry, I don't know what that little squiggly was. That was an error. So we have Eg equals Eg plus E dissipated. And let's be careful with our numbers. We're going to have 2 times 10 times 10 equals 2 times 10 times 9 plus E dissipated. And when we actually isolate E dissipated, we'll end up getting 20 joules as the dissipated energy. Awesome. All right, so let's go ahead and get this speed in part A. V is at plus v naught. Yay. So that's going to be v is 0.4 times 2 plus 0. That's going to give me 0.8 meters per second. Yippee. Now how far does it travel in 3 seconds? Interesting question. Let's solve it. X is 1/2 at squared plus v naught t plus x naught. When we plug in our numbers, that's going to be 1/2 times 0.4 times 3 squared plus 0 times 3 plus 0. So this is going to end up being 0.2 times 9, which ends up being 1.8 meters. Very nice. Now for G period only. We have the car starting at 0 meters, the accelerating car at 0. And then we have the buggy at 2 meters. And so let's be really clear. The equation for the buggy is x buggy is going to be well, it moves at constant velocity, so that's going to be negative 0.4 times t plus 2, negative because it's going backwards. And x for the car is going to end up being 0.4 times t squared. All right, that's a nice little problem. So let's say actually now they're going to meet at the same position in time. So this is part C continued. So we're going to end up getting that 0.4 t squared. They meet at the same position in time. That's what a collision means, is negative 0.4 t plus 2. I'm going to do something unusual. I'm going to simplify this algebra a little bit by dividing both sides by 0.4. Plenty of ways you can solve this. Okay, I'm just choosing this way. This is not required. So I'm going to say t squared, okay, plus t minus 5 equals 0. And this is not something we can easily factor. We'll need to use the quadratic formula. So t is negative 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 5 all over 2. So this ends up being the time that we want to keep is going to be negative 1 plus the square root of 21 all over 2. And then we'll plug that back in and get the position. So let me just do that really quickly right now. So all right, so that divided by 2 gives us 2.79. We check the so it's minus 1. Sorry. All right. So that's going to be 1.79 seconds. And where they meet, that's going to be x equals 0.4 times 1.79. And that's going to work out to 7.16 times 0.4. So 0.72 meters. Very nice. So that's page 5. We'll move on to page 6 in the next video.